Officials say there's now more water in Tulare Lake than in some of the state's reservoirs, but fears have eased of extreme flooding in surrounding communities.
Lake Tulare was never supposed to come back. For more than a century, it existed only in history books, a vast inland sea that once dominated California's Central Valley, then vanished under farms, highways, and entire communities. It had been drained, diverted, re-engineered out of existence. But now it's rising again, slowly at first, then all at once. And as the waters return to a basin that has been dry for generations, something deeply unsettling is beginning to surface. This isn't just a flood story, because what's emerging from the rebirth of Tulare Lake may signal something far more dangerous than rising water. For years, California was trapped in drought. Reservoirs shrank into cracked bowls of mud. Wells were drilled deeper and deeper. Farmers followed land. Entire towns imposed strict water restrictions. The state needed rain. And then it came. In late 2022 and early 2023, a relentless chain of atmospheric rivers slammed into California. Storm after storm pushed inland from the Pacific, unloading historic rainfall across the state. In the Sierra Nevada, snowpack piled up to levels not seen in decades. Snowpack measurements exceeded 250% of average in some regions. At first, it felt like relief. Reservoir levels began climbing. Rivers flowed with renewed force. Parched land absorbed long-awaited moisture. But as the weeks passed, relief turned into pressure. Dams approached capacity. Spillways opened. Rivers swelled beyond their banks. And the excess water began flowing somewhere it hadn't filled in nearly 100 years, the ancient Tulare Basin. That's when experts began to worry, because Tulare Lake isn't just another reservoir that overflowed. Historically, it was the largest freshwater lake west of the Mississippi River. At its peak, it covered more than 800 square miles, larger than many modern cities combined. Fed by four major rivers, the Kings, Kaweah, Tulare, and Kern, it had no natural outlet to the sea. Water collected in the basin and either evaporated under the valley sun or seeped into underground aquifers. For thousands of years, it was a thriving ecosystem. Native American tribes built communities along its shores. Wetlands flourished with migratory birds, fish species, and Tulare reeds that gave the lake its name. It wasn't just a lake, it was a lifeline. But that lifeline would not survive the arrival of industrial agriculture. By the mid-1800s, settlers recognized the basin's rich soil. They began carving irrigation canals into the valley floor, redirecting rivers toward expanding farmland. Each diversion reduced the water reaching the lake. Each new canal tightened the noose. Within decades, Tulare Lake began shrinking dramatically, and by 1999, it was gone, completely dry. For the first time in recorded history, the basin held no lake at all. What remained was opportunity. Farmers moved in quickly. Reclamation districts formed. Levees were built to control seasonal flooding. The former lake bed became some of the most productive agricultural land in the world. Almonds, pistachios, tomatoes, cotton. Entire towns rose where fish once swam. The lake became a memory. But geologists never forgot something critical. Tulare Basin had always been a natural floodplain. Long before canals and levees, the region cycled between dry and wet periods. In exceptionally rainy years, the lake would partially reappear. Locals even gave it a name, the Ghost Lake. Still, those reappearances were temporary and limited, nothing like what's happening now. Because this time, the scale is different. Satellite imagery from early 2023 revealed something startling. Water was pooling rapidly across thousands of acres of farmland. Roads disappeared beneath shallow sheets of blue. Entire crop fields were swallowed in a matter of days. At one point, the revived lake stretched across more than 100,000 acres, and it wasn't done growing. But here's what makes this resurgence uniquely dangerous. The land beneath the water has changed. Over the past decade, intense groundwater pumping during drought years caused parts of the San Joaquin Valley to sink, a process known as subsidence. In some areas, the ground dropped by nearly 15 feet. That subtle sinking reshaped the ancient basin, making it deeper in certain sections than it had been historically. In other words, the bowl holding the water is now larger. And as snowpack in the Sierra Nevada begins to melt, even more water is poised to flow into it. That snowpack represents millions of acre-feet of frozen runoff waiting for warmer temperatures. If melt occurs gradually, impacts may be manageable. But if heat spikes suddenly, rivers could surge again, and Tulare Lake could expand far beyond current projections. Communities closest to the basin are already feeling the strain. In Corcoran, home to roughly 22,000 residents, levees designed decades ago are being reinforced around the clock. Emergency crews monitor weak points daily. In smaller communities like Allensworth, evacuation warnings have been issued during peak flooding events. Dairies have relocated cattle to higher ground. Farmers have watched entire seasons of crops vanish underwater. More than 1,000 structures in Tulare County have sustained damage. But even that may only represent the beginning. Because once water reaches the historic lakebed, removing it is extraordinarily difficult. There's no natural drainage outlet. Engineers can divert some flow into canals and aqueducts. They can pump. They can reinforce barriers. But ultimately, evaporation plays a major role. And evaporation takes time. Meanwhile, the lake sits, spreading, settling, reshaping the valley floor. And this is where the story takes a more troubling turn. Because flooding is visible, the deeper risks are not. Flooding is immediate, you can see it. Fields submerged, roads closed, homes surrounded by water. But what makes Tulare Lake's return especially dangerous isn't just the water above ground. It's what's happening beneath it. For decades, the San Joaquin Valley has relied heavily on groundwater extraction. During prolonged drought, farmers drilled deeper wells to sustain crops. Entire agricultural systems became dependent on what lay hidden underground. That relentless pumping caused the land itself to compress. When groundwater is removed faster than it can be replenished, soil compacts, the surface sinks. This process, subsidence, reshaped parts of the Tulare Basin in ways most residents never noticed, until now. In certain areas near Corcoran, land has dropped by more than a foot per year over the past decade. In total, some sections have sunk nearly 15 feet. That means levees originally built to withstand historic flood levels may now sit lower relative to surrounding terrain. And when water finds the lowest point, it stays there. Engineers are working urgently to reinforce existing barriers. Massive earth-moving equipment operates around the clock, raising levees by several feet in vulnerable stretches. But reinforcement has limits, because the volume of water entering the basin is staggering. The Sierra Nevada snowpack, sometimes called California's frozen reservoir, holds millions of acre-feet of water. As temperatures rise into late spring and summer, that snow begins melting into rivers already swollen from winter storms. And the timing of that melt is critical. A slow thaw could ease pressure. A rapid heat wave could send a sudden surge downstream. Meteorologists are watching temperature forecasts closely. But forecasts only provide probabilities. They do not guarantee outcomes. Meanwhile, satellite imagery continues to document the lake's expansion. Photos captured just weeks apart show dramatic transformation. Dry grids of farmland replaced by reflective sheets of water stretching towards the horizon. At its widest point, the revived lake has spanned nearly 10 miles across. And while 5 to 7 feet of water may not sound extreme, across thousands of acres, that depth represents enormous volume. Water heavy enough to shift soil composition, heavy enough to undermine roads, heavy enough to strain aging infrastructure. And the economic cost is mounting. Tulare County sits at the heart of one of the most productive agricultural regions on Earth. Billions of dollars in crops move through this valley annually. Almond orchards that took years to mature now stand partially submerged. Tomato fields intended for national distribution lie ruined. Dairies, a major economic driver, have relocated herds, absorbing significant losses in the process. Thousands of farm workers face reduced hours or temporary unemployment. But this isn't just about agriculture. Critical infrastructure has also been affected. Construction projects, including segments of California's high-speed rail initiative, have experienced delays due to saturated ground conditions. Transportation routes connecting rural communities have closed intermittently. Emergency responders must navigate newly formed waterways that didn't exist months ago. In some cases, rescue teams have used airboats to reach stranded individuals. Yes, airboats in farmland. The Kings County Sheriff's Office acquired specialized watercraft to patrol areas that were once dry fields. Residents have been warned repeatedly, stay away from the water.
Because the lake bed is unstable, sediment beneath shallow water can act like quicksand, trapping vehicles and people unexpectedly. Several drivers have already learned this the hard way. But as dramatic as these scenes appear, officials emphasize that current flooding may represent only phase 1. Because once water settles in the basin, managing it becomes a complex balancing act. Diversion canals redirect some flow toward the California aqueduct, supplying water to urban centers further south. Reservoirs capture what they can. Some floodwater is intentionally spread across designated recharge areas to replenish aquifers depleted by drought. On paper, this sounds strategic. In reality, the system is operating near its limits. According to water resource officials, the sheer volume of runoff exceeds the designed capacity of many facilities. And once water spills into the historic lakebed, options narrow dramatically. Pumping is expensive. Diversion infrastructure has maximum thresholds. Evaporation is slow. And summer temperatures introduce a new variable. Because as the water lingers, conditions begin to change. Warm, shallow water combined with nutrient-rich agricultural runoff can create ideal environments for algae growth. Algae blooms are not uncommon in stagnant systems, but certain types can produce toxins harmful to wildlife, livestock, and humans. Monitoring teams are already sampling water quality, but that's not the only concern forming beneath the surface. Floodwaters that sweep across farmland collect more than soil. They carry fertilizers, pesticides, industrial residues. When these materials settle, they don't simply disappear, they concentrate. And in a basin without natural drainage, contaminants have fewer escape routes. Some may bind to sediment, others may seep downward, toward groundwater. And groundwater in parts of the Central Valley has long struggled with nitrate contamination from agricultural practices. When floodwaters saturate soil deeply, they can mobilize those nitrates, pushing them into drinking water systems. For communities already grappling with water quality challenges, this raises urgent questions. But we're still only scratching the surface, because beyond contamination, beyond economic disruption, beyond infrastructure strain, a more persistent threat is beginning to take shape, one that doesn't rely on dramatic surges or collapsing levees, one that thrives quietly in standing water. And this is where the situation becomes significantly more concerning. Standing water doesn't just sit, it changes. As Tulare Lake spreads across the basin, shallow pools form along its edges, warm, nutrient-rich, and largely undisturbed. And those conditions are ideal for one of the most underestimated threats in prolonged flooding events: mosquito population explosions. When stagnant water lingers for weeks or months, mosquito breeding accelerates rapidly. A single female can lay hundreds of eggs at a time. Multiply that across thousands of acres of shallow water, and the scale becomes staggering. Public health agencies in the region are already increasing surveillance, because the Central Valley has experienced West Nile virus outbreaks before. But what makes this event different is duration. If Tulare Lake persists through summer, under high temperatures, mosquito life cycles shorten, populations grow faster, transmission risk increases. And that's only one biological consequence. Warm, shallow lakes rich in agricultural nutrients can trigger harmful algae blooms. Some blooms produce toxins that affect the liver and nervous system. Livestock that drink contaminated water can become ill. Wildlife can die in large numbers. Human exposure, even through skin contact, can lead to severe symptoms. Monitoring is occurring, but monitoring doesn't eliminate risk. Because this lake was not designed, it reassembled itself, and the basin it fills today is layered with more than soil. Decades of farming mean decades of chemical application. Fertilizers, herbicides, and pesticides have accumulated in sediment over generations. When floodwaters turn across that land, they mobilize residues long embedded in the earth. Some contaminants dilute, others settle in concentrated pockets. But here's the deeper concern. The Tulare Basin plays a critical role in groundwater recharge. When water seeps downward, it replenishes aquifers relied upon by millions. If that water carries elevated nitrates or chemical residues, contamination doesn't remain on the surface. It travels.
Water treatment systems can manage certain levels, but rural communities often operate on limited infrastructure budgets. Many already face challenges meeting safe drinking water standards. A prolonged flood event increases strain on those systems. And this is where the crisis extends beyond a single season. Because Tulare Lake's return isn't happening in isolation, it's unfolding in a climate pattern scientists describe as hydroclimate whiplash. Long, punishing droughts, followed by extreme precipitation, then back again. Dry soil hardens and repels sudden rainfall, increasing runoff speed. Rivers spike faster. Floodplains fill more aggressively. The system swings between scarcity and excess. An infrastructure built decades ago was not engineered for such volatility. Experts warn that what we are witnessing may represent a preview, not an anomaly. Climate projections suggest atmospheric rivers could intensify as global temperatures rise. Warmer air holds more moisture. When storms release that moisture, rainfall becomes more concentrated, which means future winters could replicate or exceed current conditions. And if Tulare Lake does not fully evaporate before another wet season arrives, the basin may begin the next cycle already partially filled. That compounds risk. Levees stressed for months weaken over time. Soils remain saturated. Groundwater tables rise unpredictably. Each layer builds upon the last. Meteorologists have issued cautious but clear warnings. The coming winters remain uncertain. Long-range forecasting cannot guarantee a dry reprieve. And residents know this. Community meetings in Kings and Tulare counties are filled with difficult questions. How long will the lake remain? Will insurance cover repeated flood events? Can levees continue to be raised indefinitely? What happens to farmland that remains underwater for consecutive seasons? Some officials now refer to Tulare Lake not as a temporary flood, but as a multi-year water management event. That phrasing matters because it shifts the narrative from emergency response to adaptation. If the ghost lake lingers, land use planning may need revision. Crop patterns may change. Infrastructure may require redesign. And billions of dollars in economic forecasting could be recalculated. But perhaps the most sobering realization is this. The lake is not malfunctioning. It is behaving exactly as this basin always has during extreme wet cycles. For over a century, human engineering suppressed it, diverted it, controlled it. But the landscape remembers. When enough water returns, the basin fulfills its original function. It becomes a lake. As summer temperatures rise, millions of acre-feet of snow still rest in the Sierra Nevada. The pace of melt will shape the next chapter. A gradual thaw could stabilize conditions. A sudden heat wave could test every barrier at once. And beyond this summer lies the greater unknown, the next winter. Will it grant recovery or reinforce permanence? From satellite view, Tulare Lake glimmers across the valley floor, a vast reflective reminder that landscapes are not static, they are negotiated, between climate and concrete, between rivers and regulation, between memory and modernity. The Ghost Lake has returned, not as a myth, not as a curiosity, but as a force reshaping one of America's most productive regions. And while officials work tirelessly to manage its spread, the broader question remains unresolved. Is this a temporary resurgence or the beginning of a new era for California's Central Valley? Only time and weather will answer that.
Until then, Tulare Lake stands as both warning and revelation, a reminder that history does not disappear. Sometimes it waits, and when conditions align, it rises. If you found this exploration valuable, consider subscribing for more deep dives into the forces reshaping our world, because the most powerful stories aren't always new. Sometimes they're ancient, returning.